Hello everyone. What we're going to focus on is formula requiring the removal of roots. But before I show you how to do that, there is a very important concept that I want you to bear in mind. So let's say you are given the square root of x and you want to remove this square root sign. One way of doing that is to square it, right? Now, by squaring it, it allows you to remove the square root sign. So let's prove it using indices. Now, we know that when we find the square root of anything, it's the same thing as raising what's under the root sign to the power of half. So the square root of x is the same thing as x raised to the power of 1/2. All squared, right? Then what we can do, can apply the power to power rule, which says the power outside of the bracket is used to multiply the power inside. So that's going to give us x raised to the power of 2/2. Then when we simplify this, this is going to give us x to the power of 1, which is just x. So what really happened is that by squaring, it allows us to remove the square root sign. So another way to look at this is to say that the square root of x all squared, what happened is that this 2 on the outside cancel out the square root sign and just leave you back with x. And so this is also true if you have now and you want to remove the cube root sign, you remove the cube root sign by by cubing. And we can apply indices to see that. If we apply indices, the cube root of x is the same thing as x raised to the power of 1/3 all cube. And then we apply the power to power rule, and 1/3 times 3, that's going to give us x to the power of 3/3, which is going to equal to x to the power of 1, which is just the same thing as x. So the cube root sign disappeared. So another way to look at it is to say that, all right, if you have the cube root of x and you want to remove this cube root sign, all you do is to cube, and then by cubing it, the 3 on the outside cancel out the cube root sign, that just leave you back with x. Alright, so that's how you remove a root sign. So what we're going to do now is to use that principle to apply it to this example. So the first example is make t the subject of the formula. We're given a formula, right? The formula is v is equal to the square root of t over m. And we want to manipulate this formula to make t the subject. First thing we have to think about is how can we remove this square root sign? We can remove the square root sign by squaring both sides, right? So we're going to transfer the square root sign to the other side of the formula by squaring both sides. Now, by squaring both sides, the square on the outside here will cancel out the square root sign on the inside. And then on the right, what we will have is just t over m. And on the left, what we'll have is just v squared. So we have to look at what is happening to the t here, because remember that we want to make t the subject. So realize that this t is being divided by m. So in order to transfer the m to the other side of the formula, we can do that by doing the opposite, which is to multiply both sides by m. All right, so to multiply both sides by m. Going to multiply this side by m as well. Now clearly here, m in the denominator will cancel out m here in the numerator. So what we left back with here is just t is equal to m v squared. Right? Now t is now the subject, but we normally write the subject on the left hand side. So we're going to write a final statement to say therefore t is equal to m v squared, and we're finished there. Now let's look at the second one. Here it says make v the subject of the formula. R is equal to the cube root of 3v over 4 pi. So we know we're given R, right? A formula which is R is equal to cube root of 3v all divided by 4 pi. Now, first thing we have to think about is how can we get rid of this cube root sign, right? We can get rid of the cube root sign by cubing both sides. So we're going to cube this side, and we're going to cube this side as well. So note there that this 3 here will cancel out the cube root sign. So what you are left back with on the right hand side here is just 3v all over 4 pi. And on the right, what you have is just r raised to the 3rd power. Right? Now you pause at this time again and you ask yourself, what do you want to make the subject? We want v to be the subject. But we notice here that 3v is being divided by 4 pi. So what we need to do is to transfer this 4 pi to the other side of the formula first. Right? How can we transfer this 4 pi to the other side of the formula? We can do that by doing the opposite of dividing by 4 pi, which is to multiply both sides by 4 pi. We're going to multiply this side by 4 pi. We're also going to multiply this side here by 4 pi. Right? What will happen is that 4 pi here in the denominator will cancel out 4 pi here in the numerator. Right? So what that leave you back with is just 3v. And over here, what you have is just 4 pi r cubed. Right? Now, you pause again. You want to make v the subject. What is happening to the v? The v here is being multiplied by 3. So what you need to do is to transfer this 3 to the other side of the formula. And how can you transfer 3 to the other side of the formula? By doing the opposite, which is to divide both sides by 3. So we're going to divide this side by 3. And we're also going to divide this side by 3. And here now, clearly you can see that this 3 in the numerator will cancel out the 3 in the denominator, right? And what you're left back with here is just v, and over here it will end up with 4 pi r cube all divided by 3. And all you need to do is to just write a final statement, which is to just rewrite this, put the subject on the left. So you just say, therefore, V is equal to 4 pi r cube all divided by 3. And you're finished with that one. Now to example 3, says make G the subject of the formula T equal to 2 pi times the square root of L over G, right? So we're given the formula T is equal to 2 pi times the square root of L all over G. Now we are asked to make G the subject, right? But before we can even make G the subject, first thing that we'll need to do is to transfer 2 pi to the other side of the formula. Why is this so? 2 pi is multiplying the square root of L over G. So that means we need to get rid of the 2 pi first. So we notice that the 2 pi is multiplying. So in order to get rid of the 2 pi, what we can do is to do the opposite, right? Divide this side by 2 pi. And we're also going to divide this side by 2 pi. Right? What you notice is that this 2 pi in the denominator will cancel out this 2 pi in the numerator. Right? So what you're left back with on the right is just the square root of L over G, right? And on the left hand side, you just write back what you have, which is just T over 2 pi. Now at this stage, bear in mind that we still want to make G the subject. What is happening to L over G? We are taking the square root of that. So we need to remove the square root sign, which means that we want to transfer this square root sign to the other side of the formula. How can we do that? We can do that by squaring both sides, right? So we're going to square this side. We're also going to square this side. Right? By squaring both sides, what it does is that this 2 on the outside, which is the power, will cancel out the square root sign. Right? So what we're left back with here is just a fraction, which is L over G. And we can just apply a little bit of indices to this. And if we T over 2 pi all square means 2T over 2 pi times T over 2 pi. And that what that will give us is just T square all over 4 pi square. Now, note that we want to make G the subject and G is in the denominator. And we know that our subject cannot be in the denominator. So how can we get G to be in the numerator? We can get G to be in the numerator by multiplying both sides by G. Right? So what we're going to do is to multiply this side by 3. And we're also going to multiply this side by G. Sorry. So if we multiply both sides by G, clearly here you can see that G in the denominator will cancel out G in the numerator here. And what we're left back with, and this side is the numerator, which is L. Right? And over here, what we have is G times a fraction, which is T squared over 4 pi squared. Right? Now we have one final thing to do. We need to get G by itself. You have to remember that. Now this fraction here, which is T squared over 4 pi squared, is multiplying G. Now in order to get rid of this fraction, or to transpose this fraction to the other side, then we can do the opposite, which is to divide both sides by the fraction, right? So if we divide this side by T squared over 4 pi squared and also divide this side by T squared over 4 pi squared, then clearly what's inside of the bracket here, we cancel out what's in the denominator here. So that leaves us back with G there. So on the left hand side we have G is going to equal to, we can clean up this. So here we have L is being divided by a fraction, right? So this is going to equal to L times 4 pi square all over T square. Right? And we're finished for this one. So just remember that dividing by the fraction here is the same thing as saying L times 4 pi square over T square. Alright, for the last one now, we have make M the subject of the formula. V equal K times the square root of FL over M. So we know that we have been given V, right? And V is been equal to K times the square root of FL all over M. I want to make M the subject. Again, first thing we need to get rid of is K. Why? K is multiplying the square root of FL over M. How can we get rid of the K? By dividing both sides by K. So we're going to divide this side by K. We're also going to divide this side by K. Clearly, K here in the numerator will cancel K in the denominator. So what we're left back with here on the left, we're just going to write back what we have, which is just V over K. And on the right, what we'll now have is just a square root of FL divided by M. At this stage now, we need to get rid of the square root sign. How can we get rid of the square root sign? By squaring both sides. So we're going to square this side and square this side as well. Alright. So notice now, by squaring both sides, what it allows us to do is that this 2 will cancel out the square root sign, right? So what we're left back with on the right here is just a fraction, which is FL all over M. And then this V over K all squared means V over K times V over K. So this is just the same thing as V squared over K squared. Alright. Now we realize again that the subject that we want is in the denominator. And we know that the subject cannot be in the denominator. So how can we get it in the numerator? It's just to multiply both sides by M. So we're going to multiply this side by M. And we're going to multiply this side by M. When we multiply both sides by M, M in the denominator here will cancel out M in the numerator. So what we're left back with here is just the numerator, which is FL, all FL is equal to M times the bracket here, which is just V squared over K squared. Right? Now at this stage now, you need to remind yourself what you want to be the subject again. We want M. So now M is now in the numerator. Okay, what is affecting the M? Whatever is inside of this bracket is used to multiply in the M. So how can we transfer what's inside of the bracket to the other side? By doing the opposite, which is to divide by what's inside of the bracket. So what we're going to do is to divide both sides here by K squared by V squared over K squared. But whatever you do to one side, you must do it to both sides. So we're going to divide this side as well by V squared over K squared. Now, what will happen is that what's inside of the bracket in the numerator will cancel out what's in the denominator. So that is going to leave us back with just m here. And FL over v squared k squared, this is the same thing as FL times k squared over v squared, right? So all this is going to equal to, m is going to equal to f L k squared all over v squared. And you are finished there. And that's it.